So for today, our lesson would be focusing on right triangles, special right triangles, and trigonometry. So let's get started. First, let's review some basic right angle triangle stuff. Most middle school and high school people know about this formula. This is the famous Pythagorean theorem formula. So this formula tells us if you have a right triangle that the base squared plus base squared is equal to hypotenuse squared. Or in other words, a squared plus b squared equals c squared. So as you can see, this is a pretty basic formula. We have all seen in school, and we have all seen this formula in middle school, and yeah. So just this is simpler formula for calculating hypotenuse would be c is equal to square root of a squared plus b squared. So yeah, I did square roots on both sides, and yeah, this is a pretty easy concept that that we have all.
Yeah? Okay.
I just wanted to tell you guys that I'm recording this, so could you please not do that? All right, let's look at two practice problems. So y would be equal to 12 squared minus 8 squared is equal to y squared, right? So 12 squared is basically 144 minus 64 is equal to y squared. So 144 minus 64 is 80. And then we take the square root, so 80, square root of 80 is equal to y. And then we could kind of see, we could simplify this, and then that would be 4 square root of 5 is equal to y. So yeah, most people have seen this. This is just a basic review of concepts, and let's take a look at this one. So this problem is pretty easy to do because if you know the Pythagorean theorem, triplets, so that's 3, 4, 5, you can see that 6, 8, and x are multiples by just multiplying 2. So you don't even need to calculate, you could just go and say that x is equal to 10 by multiplying 5 times 2, okay? All right, I know this is frustrating stuff because it's so easy. We have seen this like 1,000 times in school. I just need to go over it. Now let's dive into the real stuff, okay? Pythagorean theorem proves. I just put it on here. So if you have like a cube at 3 sides, so it forms like a cube which has the area of 9. And then if you have a cube with 4, like measure 4 by 4, that's area 16. Sorry, 16. And then you do 9 plus 16 is 25. So area 25 squares right here with a side 5. So it's like a pretty basic proof. So there are many other ways to prove the Pythagorean theorem using Garfield's and Bosker's formula. Now, let's get into the actual real stuff we're going to talk about today, okay? Special right triangles that most of you, I hope, have not seen this yet, okay? These are two types of special right triangles, 60, 30, 60, 90, meaning that one angle is 30 degrees, one angle is 60 degrees, and the third one is 90 degrees, as you can see here, not 90, 60, 30. And the second is 45, 45, 90 degree triangle. The two sides opposite to 45 degrees are equal, meaning this side and this side, which are opposite to the 45 degree angle, are equal. You might be wondering, why are we going over these triangles? Can't you just use the Pythagorean theorem? But we go over these triangles and study the concept because when we see these patterns, we don't need like a calculator or even need to calculate. We could just go straight from having the measure of one side and then go and write the measure of the other two sides, okay? As you can see, in a 30, 60, 90 triangle, the side opposite to 30 degrees is measure x. So x is a variable. The side opposite to 60 degrees is x times the square root of 3. So this is always true for any triangle measuring 30, 60, 90 degrees, okay? And then the side opposite to 90 degrees is 2x, meaning 2 times x, okay? So let's take an example. So if x equals 3, if x equals 3, then this side, okay, I'll just use a pointer. If x equals 3, then this side is equal to 3 times square root of 3. And this side, the hypotenuse is equal to 6. Like, it's that simple. If you remember this, you don't even need to like calculate anything for these kinds of problems. And they are pretty common on the SAT. Like, I would say about 50 points on the SAT. Okay. And then for 45, 45, 90 degrees triangle, you see that the sides opposite to 45 degrees are equal. And then the hypotenuse is just x times the square root of 2, right? That's pretty basic. Now let's say if x equals 2, you don't need to take out a calculator and calculate the hypotenuse. You could just say, oh, the hypotenuse is equal to 2 times the square root of 2. Pretty easy, right? Oh. All right. Now let's take a look at some practice problems. All right. So we have a 30 degrees here, 90 degrees, using our simple basic old formula that all angles add up to 180. We know that this is equal to 60. So now we need to calculate x, right? We know that the side opposite 30 degrees is 6. So the side opposite to 90 degrees, or the hypotenuse, would be 2 times 6, which is equal to 12. Simple. And this side, AC, would simply be 6 times square root of 3. No calculation needed, okay? Very simple. This side too. Now, using our 180 degree rule to say that this is 45. And now we know that the hypotenuse is x times square root of 3, or so that would be 3 square root of 2 is equal to x, right? Pretty easy. So this is all easy basic stuff. I just want you guys to remember these formulas and take some notes on these. Now let's look at some multi-step problems. Okay. So let's look at the first one. Now you would think, okay, that's a 60, that's a 90. So we know that this one is 30, right? And this one is 32 because 60, 90, 30. Now we need to calculate x. X is opposite to 60 degrees. And this over here, it's opposite. So 5 is opposite to 60 degrees. And we see that we have a common side, this one, right over here, right? So we need to find the measure of the common side, okay? So the common side is opposite to the 30-degree angle. We know that if this side is x, we already have the variable x. So let's call this y. If this is y, then 60 is y times square root of 3, right? For a 30, 60, 90 triangle. In order to calculate y, just do 5 over square root of 3. So now remember, you can't have a square root in the base, so you would just multiply by square root of 3 over square root of 3, which would give you 5 times 3 over 3. So yeah, that's the side, and that's the length of the common side, and it's also opposite to the 90-degree angle. So we know that the 90-degree is always double the value of the side opposite to 30 degrees. Okay, so if for this one, this measure right here, we could find by just dividing this by 2, which would equal to 5 times square root of 3 over 6, right? And now, in order to find x, we just multiply this by square root of 3, right? That would be square root of 3 times square root of 3 is 3. So that would be 15 over 6. Now we simplify. That would be 5 over 2, right? Pretty easy. Okay. Now I want to go over question 14. So we have x right here. Okay. So we see that 6 is opposite to the 60-degree measure, and we have a common side that is opposite to 90 degrees and a 45 degree in this case, okay? 45. Pretty easy, right? Yeah. So we first need to calculate this side that is opposite to 90 degrees. So this is 30. This is 30. So in order to find the side opposite to 30 degrees, we just divide this by square root of 3. So that would be 6 times 6 divided by square root of 3 times square root of 3 over square root of 3. That's just 2 square root of 3. The side opposite to this, and the common side is times 2. That's equal to 4 times square root of 3, right? Now we see that this side is opposite to 40 degrees. So in order to calculate x, we see that it's opposite to 90 degrees. So we just multiply this by square root of 2. That would be 4 times square root 6. Pretty easy, right? Cool. Do you guys have any other questions? I would love to take some questions at this point. Try to talk to me. All right, so let's now move on to some harder stuff. All right. You might be saying, what area of the triangle once again? No way. But now, I want to show you another formula, okay, for the area of a triangle. I know this formula, you would never see this formula in the school, okay? Like never. But this formula is really good for doing SAT math and some competition math, okay? We all know the formula 1 times base times height for any triangle. And for an equilateral triangle, side squared times square root of 3 over 4, right? But there is one more formula to calculate the area of a triangle when you have a circle inside that triangle and you're given the radius, okay? This formula shows up like a lot of times on the SAT and on competition math like AMC and math counts. So this is what I'm talking about. You have a circle inscribed inside a triangle, okay? Now you would, so I will show you the formula, how to use it. So first we find out the perimeter. That using variables, that would be a plus b plus c, right? Okay, and then we have radius r. Now there's a thing called semi perimeter or half of the perimeter. So half of perimeter would be a plus b plus c over 2, right? Right? Right. So we call this S or semi perimeter, and then we have R. So the simple formula, the area of these kinds of triangle are very easy, okay? That's the radius of the circle times the semi perimeter. Easy? Easy, I know, pretty easy, right? Let me just write it in a better way. That's radius of the circle times the semi perimeter. Okay, this is pretty easy concept. Okay, if you remember this, I would guarantee that you would at least do one. You would at least get one problem out of 25 problems on the AMC using this formula. Okay, they would never teach you this formula in school, but I just want you to know this formula because you guys are taking advanced math class this summer, so why not just know this? Okay. Now, let's move on to everything that you guys have been waiting for, okay? Trigonometry. Okay, trigonometry. So there are three basic trigonometric functions that you need to know about: Math 1, Math 2, and most of Math 3. You would do advanced functions in pre-calculus or calculus. There are three functions that we're going to talk about today, okay? Sine, cosine, and tangent. You need to remember that trigonometry works only in a right triangle, okay? And so sine of A. So angle A, it's talking about angle A. Sine of angle A is opposite over the hypotenuse. Pretty easy, right? So what side is opposite to angle A? The blue one. And what's the hypotenuse? The purple one, right? Cosine of A, on the other hand, is adjacent over the hypotenuse. Adjacent is the pink line, and then hypotenuse is the purple one. And then tangent is opposite over the adjacent. Okay, so opposite over the adjacent. So you might have heard of this acronym, SOHCAHTOA. So this is an easy way to remember SOHCAHTOA. Okay, so sine opposite over hypotenuse, ka cosine adjacent over hypotenuse, and TOA tangent opposite over the adjacent. So use the mnemonic SOHCAHTOA in order to easily remember the three trig ratios, okay? These are very, very, very important for Math 1, Math 2, and Math 3, okay? You guys might have already known these, but I'm going to show you some advanced stuff in the coming slides. So let's go over these. So let's find out cosine of angle F. Cosine, okay. So let's see what cosine is. Cosine is adjacent over the hypotenuse. So hypotenuse is 13. So adjacent is 5. So that's equal to 5 over 13. And you can plug it into your calculator to find whatever the value that is. Okay, let's see sine of E. Sine is opposite over the hypotenuse. That is the same thing, isn't it? 5 over 13. Now, okay, so let's think about it. Why are these same? Okay, so if this angle is 90 degrees, let's say this is X, then this angle is equal to 90 minus X. Remember that, okay? This is going to play out when we look at co-functions, okay? Okay, and then tangent of X, tangent of F is equal to 12 over 5, okay? Opposite over the adjacent. Pretty easy, right? And then you can plug it into a calculator and do whatever the heck you want. Okay, tangent of G. Let's take a look. Tangent is opposite over the adjacent, 15 over 18. Right? Right. Cosine, on the other hand, of H is 15 over 17. Right? And sine of H is 8 over 17. Make sure you guys understand this. And cosine of G is equal to 8 over 17. Oh, yeah. Okay. Again, why are these similar? This is right angle. X, 90 minus X. Right? Why are these same? Okay, remember that I'm gonna talk about this in the future. All right, let's move on. Let's look at inverse trig functions. By inverse functions, I do not mean 1 over sine theta, okay? That is not what I mean. I am not talking about negative exponentials, okay? I am not talking about negative exponentials. I am talking about, so in previous problems, we were given an angle, and then we found out opposite over hypotenuse or adjacent over hypotenuse or opposite over adjacent or whatever, okay? But what if in a problem, you're only given the sides, or AKA, you're only given opposite over hypotenuse, and then you're told to calculate the angle. In this, you're going to use inverse trig functions, okay? So that would be sine to the -1. Obviously, these are not exponents, so sine over -1 is not the same thing as 1 over sine. Remember that. So each of these, it's basically the same thing, just when you need to calculate theta, right? So these are very helpful in order to find out the angle measures. All right. So let's look at some practice problems. So I want you guys to take a calculator and try doing these problems on your own. I would give you 2 minutes. Is that okay with everyone? Application of trigonometry, okay? Elevation and depression. Okay, so let's see. So angle of elevation, as you would know, is basically the angle at which a thing is going up from a flat surface. And angle of depression is basically the angle at which a thing is going downwards, okay, downwards from a flat or smooth surface, as you can see here. So I want you guys to take 2 minutes to do this problem and then tell me what the angle tell me what the angle of elevation is from Aya over here to the Supergirl, okay? I want the angle of elevation, okay? Make sure that I get the angle of elevation. I have 2 minutes. Now, if you want to calculate the angle of depression from the Supergirl to Aya, we would be calculating this angle right over here. Okay, so this is also 9, this is 12. All right, so we use the same thing, tangent. Yeah, tangent. Or 9 or 2, 9 or 12, which is basically 36, right? I hope this is good. Sorry guys for the technical difficulty I had 20 seconds ago. All right, so let's look at this problem. This is a classic angle of elevation problem, okay, that you would encounter all your life, literally all your life. All right, so let's take a look at this problem. It says Barbara is building a wooden cabin. The cabin is 42 meters wide, and she obtained a bunch of 27-meter long wooden beams for the roof of the cabin. Naturally, she wants to place the roof beams in such an angle that each pair of opposite beams would meet exactly in the middle. What is the angle of elevation in degrees of the roof beams? Sorry. All right. So as you could see this picture, let me exit this so that I could show you a better picture. I can show you this in a better way. All right. Okay. Sorry, guys. Okay, so now let's take a look at it. So now we have this. So it says that the wooden cabin is 42 meters long, right? 42, right? So let's see what we could do about this, okay? So it says that the beams must be exactly half, right? Opposite beams should meet exactly in the middle, meaning this line, this altitude would divide this equally. So each side would now equal 21. That's 21. So in order to calculate the angle of elevation, we would simply use inverse function. Now, which one? You see, you have the hypotenuse and an angle adjacent. So naturally, you use cosine. Cosine -1. That would be 21 over 27. Now, if you have a calculator, you could calculate. This is equal to 38.94. Right? Easy stuff. I know, guys. This is frustrating. Let's move on. Alright guys, so I want to show you some really cool stuff about cofunctions and what I told you about remembering that in certain situations, sine and cosine have the same value in the same triangle. So these cofunctions are true for higher level trig functions like secant and cosecant and tangent and cotangent. Okay, but today we're going to take a look at cosine and sine. Okay, let's say that this angle right here is x. So naturally, this angle is 90 minus x, right? Because this is 90 and we know that all angles add up to 180. Now, let's take a sine of x, okay? Let's take a sine of x. Sine of x is equal to opposite over the hypotenuse. Sorry. I'm really sorry. Let's take the let's take the cosine of x, right? The cosine of x is equal to a over c, right? Ah, my bad. Cosine of x is equal to a over c, and then sine 90 minus x is equal to a over c. Now, we see that, okay? So you could draw the conclusion that cosine x being any value, okay, literally any value below 90 degrees is equal to sine 90 minus x. These are cofunctions, okay? This is true for all other cofunctions. Like if you have cosecant, so cosecant x is equal to secant 90 minus x. Okay, guys? This is true for every cofunction. Okay? This is even true for the tangent. Okay? So tangent, I should say cotangent x is equal to tangent of 90 minus x. Okay? This is how you get cosine, cosecant, and cotangent. Okay? It's basically cofunctions. Okay? So being developed that, I would recommend you knowing this because I have taken the SAT and they have about two to three questions that directly do this. Okay, they might give you sine, I don't know, sine x is equal to 4 over 5. And they might say, okay, calculate the cosine of 90 minus x. And people freak out. And I'm like, basic concept, because we know that sine x is equal to cosine 90 minus x, right? Cosine 90 minus x. So if you get this kind of problem, simply just go, that's the answer. Okay, pretty easy stuff. So for the last slide of today, I'll show you something really great. Let's talk about identities. Okay, let's talk about trigonometric identities, okay? All right. So we know that sine x is equal to cosine 90 minus x. Okay, this is true for every cofunction. Now, if we have, so if you take a look, let's say, what if we take sine to the x and square that, and take not cosine 90 minus x, but take cosine x and square that, okay? Let's visualize this, okay? When you visualize this, I'm gonna erase some stuff. When you visualize this, okay? So sine x, so let's say this is x. Sine x is equal to b over c. And then when you take the square, that's b squared over c squared. All right. And what is cosine x? Cosine x is a over c. You just do square that. It's a squared over c squared. Okay. All right. So now you might be saying, okay, that's cool, but how are we supposed to use it? All right, I'll show you how to use it. Okay. I'll just remember these. Okay. I'll write this in a better way. So you know that sine x is squared. Let's do plus cosine x squared. We know that this sine x squared is equal to b squared over c squared plus this is equal to a squared over c squared. Now we have common denominators. We could add, right? A squared plus b squared over c squared. Now we know using the Pythagorean theorem that a squared plus b squared is equal to c squared, right? That would be c squared over c squared. That's 1. This is a this is a trigonometric identity, okay? Sine x squared plus cosine x squared is equal to 1, okay? I'll write this in a better way. So sine x squared plus cosine x squared is equal to 1. Remember this, guys, okay? This would come up in a lot of questions, okay? So now it's 8 o'clock, and I guess